Good morning. I am Reggie, Associate Professor, Department of ECE. Today we are going to see about orbital perception. On completion, students will be able to understand the basic concept of low Earth orbit, understand the effect of oblateness. Low Earth orbit. The height of LEO should be high enough to avoid atmospheric drag. It ranges from 750 to 1500 kilometers. Service provided two-way message service, data communication service, position determination. Example are orbital communication corporation system. This is a low Earth orbiting satellite system. It is designed for worldwide data messaging and position determination. The system has 20 to 24 satellites in circular orbit. The altitude of the orbit is 970 kilometers. The ortho communication satellite has the design lifetime of 4 years. Polar orbit. Polar orbit are the special case of LEOs. They are almost circular orbit and the satellite in this orbit could cover the north and south pole region. Orbit altitude and inclination. Polar orbit are at a height between 800 and 900 kilometers above Earth. They have an inclination of 90 degree. Service provided. The polar orbiter, which is also known as LEOSat, provide the following service: environmental monitoring, search and rescue service, provide a wide range of data. Can be ultraviolet sensor to measure zone level. Example, Iridium is a LEO satellite constellation that consists of 77 satellites. These satellites are in polar orbit at an altitude of 765 kilometers. They are in 7 orbital plane with 11 satellites in each plane. Medium Earth orbit. Medium Earth orbit are almost circular orbit. Orbit altitude. The height of MU extends from 10,000 km to 20,000 above the Earth. Service provided. Following some of the important applications of MEO satellite are used: mobile satellite service, navigation, precision location determination. GPS stands for Global Positioning System. This constellation of 24 satellites in 12 hours orbit. The altitude of orbit is 20,182 kilometers and are inclined at 55 degree. These satellites are in 6 orbital plane with 4 satellites in each plane. Therefore, at least 6 satellites are visible from one point on Earth at all time. This system is developed for navigation, precision, location determination and time transfer between standard laboratories. Orbital perception. The ideal Keplerian orbit assumes the Earth as a uniform spherical mass. It is also assumed that only force acting in a centrifugal force which result from the satellite motion for balancing the gravitational pull of the Earth. But in actual practice, there are so many perturbing forces, disturbing forces for an orbit. The main focus on effect of non-spherical Earth atmospheric drag. Effect on non-spherical Earth. According to Kepler third law, the nominal mean motion n0 of a spherical Earth of uniform mass is given by n0 equal to square root of mu by a cube. Oblates period. The Earth is not a perfectly period. It is a bulge at the equator and flattening at the poles. This shape is called orbital period. When it taken into the account, we will have the mean motion n equal to 1 n into 1 plus ki 1 minus 1.5 sine square I by a square 1 minus e square. Anomalistic period. The orbital period of the Earth when considering its obliqueness is termed as anomalistic period. Pa equal to 2 pi by n into s, where ni is the mean motion. Effect of oblateness. Two changes in the orbital place are produced by non-spherical Earth: regression of the node and rotation of the nodes. Three things happen. The node appears to slide above the equator. If the orbit is prograde, the node slide westward and it retroid the slide eastward. Because of this, the line of node in equilateral plane rotate from the center of the Earth. Thus, the right ascension of the ascending node shifts its position. Rotation of the line of episode. There is another effect produced by equilateral bulge. Due to rotation, the argument of perigee changes with the time. So d omega by dt k into 2 minus 2.5 sine square I. Overall effect. Thus, this satellite drift as a result of regression of the node and longitudinal of perigee changes as the result of rotation of the line of episodes. Atmospheric drag. The effect of atmospheric drag were considerably only for near Earth satellite. This satellite is below 1000 kilometers from the Earth. Effect: the drag is greatest at the perigee and reduced velocity at the point. The semi-major axis and eccentricity are reduced because of the drag. Limit of visibility. There will be a east and west limit of the geostationary arc which is visible from given Earth station. These are called as limit of visibility. Longitudinal limit. Longitudinal limits can be calculated by considering the Earth on Earth station at the equator with the antenna pointing either west or east along the horizontal as shown in figure. limiting angle theta equal to AR cos of AG by A cos theta, that is 6378 by 42164. Longitudinal limit is 81.3. Limit of longitudinal calculation. The limit of visibility depend upon earth station altitude as shown in figure. Effect a minimum value of elevation. This is used to avoid reception of excessive noise from the earth. Typical value is 5D degree. Applying sine rule, the angle subtended to the satellite is found to be S is equal to R sine of R by A GSO sine of theta minimum. B is equal to 180 minus sigma minimum minus S. So from this we can understand the basic question for an elliptical orbit. The value of eccentricity will be apogee means the point nearest from the earth, point furthest from the earth, the point smallest from the earth, none of the mentioned above. Thank you.